Good afternoon, Professor. We are the group Love BDC, and our team member are Wang Nianqi and Xiao Xueting. Okay, our project is divided into 5 parts as shown in the picture. Okay, and we are introduced data 1 and data 2 separately. So let's look at the part of data 1 first. We looked at the data and found that some features were missing. After comparison, we found that the model filled with 0 had the best effect, so we choose to fill in 0. Well, the feature extraction, in the next step, we perform feature extraction to prevent information redundancy and the model overfitting. First, calculate the correlation between each feature and label. Well, as the picture shows, and test appropriate calling threshold. 0.01 and 0.02 threshold results are better, and we will compare them later. The effect of these two threshold and the model without cooling. Next, we draw a heat map to calculate the correlation and the collinearity between variables. And we can see the picture of this. Okay. All our data are continuous numerical variables, and the sample is small. And it's easy to overfit with deep learning, so we use the QDA algorithm. Okay, as we can see, the QDA algorithm. Yes, first of all, let's look at the comparison of cross-validation results. As you can see from data in the figure, we don't need to eliminate the features based on correlation, which will reduce the effects of the model. Well, the next is the 10-fold cross-validation results. Okay, and after 10 times of cross-validation results, our final model effect is as follows. We use the effect of cross-validation for the training set. Okay, and then we got the confusion matrix. And the microscopic results of WEF1, well, as you can see, is 89.33%, and the microscopic results of WEF1 is 88.86%. Okay, let's see the next. Well, the model comparison, evaluation, and feature work. Okay, and we choose 2 aspects of this. The first is algorithm effect, and we can see they are matched successfully. And next is time comparison, and our algorithm training is faster. Okay, and these are summary of discoveries and feature work. Okay, let's see the data 2. Well, after browsing the data of data 2, there are no missing value, but data 2 has different types of data, so we clean the different types of data. Yeah, as you can see, the first one. Let's look at the continuous features, the distribution of value whose minimum value is 0. Well, as you can see, this one, these two, and then examine the distribution, and the left one is attribute 8, the right one is attribute 9. Okay, next we did the discrete data encoding. Both numbers and the strings appear in variable 4. We understand the number as the number of times per mass. We use a count encoder to encode the string and replace the string with the number of occurrences. As is shown in the picture, we can see the comparison. Well, the first one is before using count encoder, and next one is after using count encoder. Okay, next is the grid search method to search for the 2 parameters criterion and the max steps. And then this pictures is the effect, and this is the model 1. As you can see, is 10-fold cross-validation results and the final effects of the model, the validation set, confusion matrix, and we find the criterion Gini impurity and max steps equal 9, and they are the best situation. Okay, and they are the model 2 situation. Well, and we print out the decision tree, and because of the size, we just put the second floor. Okay, and this is the next. And we did the improve of the basic design. First, we set the search size to 0.5 and 0.10. and there are two failures to optimize the reasons. And then we put the algorithm refactor and match successfully, and our algorithm set is faster. Okay, that's the summary.